So in this video, we're going to look at doing a little bit of transferring of files or conversion of files from PDF into AutoCAD. And just to demonstrate that, we're going to look at a typical civil engineering project. Now, this one here is for a clubhouse for a sports facility. And we're going to concentrate particularly on this little feature here, or big feature. This is to be able to regulate the amount of surface water drainage that goes into this burn here. And it goes through a couple of stages to get to that point, because here it filters the surface water in case there's any contamination in the surface water. Then it goes to a manhole, and then it breaks out into 3 different pipes here. And then in here we've got an attenuation tank, which is made up of what's called a geocellular feature. And that basically regulates the amount of water and attenuates it before it goes into the burn here. So what we need to do is we need to transfer this PDF into a CAD file, into a DWG file. You'll see there's lots of different civil engineering features that you'll come across over your career if you haven't already, like your rotting eye detail, your manhole, which is in plan here, section through that, and we did something like that back with the NC class last year. Now, this is a little bit of cheating, but it's cheating in a good way, because what we want to be able to do is to work with different types of files and be able to translate them and so on. Now, this attenuation tank here looks like this when you take a cross section through that. Okay, we're not going to focus on the filter system, and equally we're not going to concentrate too much on this bit. It's really this and this, which is the cross-sectional view of the plan here. So when you work with this file, it'll be provided to you on an email, and then you're going to take this file and then export it into, or import it into AutoCAD. So let's just go ahead and do that. This is what it's going to look like when you go to import it. And I'll also refer to some of the details that you can get on the Sustainable Urban Drainage Manual. Okay, so there's a lot of similar features that you'll find there. I'm just going to delete that for now to leave us with a blank screen. And when you have your file, you want to save it, first of all, your PDF file of that drawing that I showed you. And then the key command is PDF import, and then enter. And then it'll ask you to select the file. So you're just going to click on File, and you're going to bring up the folder that you want to take that drawing from. And in this case, it's called Drainage Details Revision B, this one here. Click that and then open it. And then you're importing this drawing into AutoCAD. So basically you're converting what we have here into some sort of an AutoCAD file. I'm going to untick this import as a block. You could keep that as a block if you wanted to. You're going to be using vector geometry here, which is basically what CAD files are all about, using vector geometry, and then just click OK on that. Now, when you click OK, it's going to start converting all of the different polylines, the different lines. Okay, and it will take a little while. So we're just going to wait for that to happen. And the thing about bringing in a PDF file is it has to have been done on AutoCAD in the first place. It can't just be any PDF file. It can't just be an image. It has to be something that was in its first format. It had to be a DWG or a DXF file, something along those lines. So once that gets imported, it's going to look like this. In this case, it's obviously rotated the wrong way. And you'll see there, when I go to click on any part of this geometry, then it's not quite the hatch pattern that we're used to, because it basically breaks everything up into smaller components, smaller features. So what we're going to do is we're going to take this and we're going to basically redraw some of the features that I was talking about. So I want to rotate this first of all. So we're going to go to the rotate command, and then we're going to select that all across with a blue box. Press enter to confirm the selection. That allows you to move on to the next stage. Then we're just going to get ourselves a base point, and we're just going to flip that round into its proper orientation, and that might just need to be moved across a wee bit. I'm not going to be too concerned here about the actual coordinates. But you can see now that it breaks up into the different lines, and what we're going to do now is we're going to just try and scale this up to something that replicates the dimensions that we've got here. Now, what I mean by that is we've got here a pipe diameter here 150. This one here, between here and here, is about 100. But if you were to go and measure that, it's not going to measure exactly as 100. In fact, far from it. If I put my snap point there, and then I get a measurement down here, it's 0.106. So in actual fact, it's almost 1,000 times less than it should be. So the way to scale it up is to draw yourself a little line. It could be 100 or it could be 150. And we're just going to go do that now. So line about here, let's say we put it about here, and we're going to draw this to be 150. So there you see the size of the line that it should be. So that's 150 from here to here. In fact, I'll just do that again. I think it's gone in 50. So line again, 150. Okay. And we need now to use that as a reference line so that we can scale this actual drain here, which is shown as dashed line. We want to scale that up to 150. So the key command, of course, is scale. And we're going to select the objects that we want to scale up. We're going to avoid the vertical line, of course. Press enter to confirm the selection. And now we want to get a base point. I'm just going to use the base point here. You could use it, you can make that base point anywhere for that matter. And then when you see down in the command line here, we've got specify the scale factor. We're going to click on reference here. So we're going to use the vertical line as our reference. And then the reference length, we can just go ahead and type that in as 150. Okay. And then confirm that. Now, that doesn't seem to have worked, so we're going to try that again. Just going to take a quick distance measurement of it. So it hasn't worked, so let's try that again. Scale, enter, base point, reference. So the reference length, specify the reference length. So the reference length is this length here. So really what we need to do is click from here to here. And then the new length, so I've obviously done that wrong. So the new length is 150. Okay, so that looks a bit better now. So if I was to go to this dimension again here, so type in DIST or use your measurement tool, So now you'll see that that's coming up as 150. Okay. Now, not all of these can be done the same way because each of these has been done to a different scale. So for example, if you were to take the scale of this, which is obviously a lot, you're zooming in a lot more into a particular detail, you're going to have to take that and do that separately and do your own scaling up with reference. So each of these has to be done separately, each of these drawings. Okay, same goes for this and also this as well. So the idea now is that we're going to copy that over, and we can work with that separately on its own. Okay, take a couple of these out as well. Now, that gives you a good idea of the kind of scale that you're working to. I would make a guess in saying even that between here and here is about 200. It doesn't actually work out exactly for you, but if you could type in, for example, distance, and then if you measure between here and here, it's very, very close to 200 millimeters. So that's a very typical dimension for a foundation, right? Because what we're looking at there is a foundation. And this is the manhole, excuse me, and this is a vent pipe or some sort of an inspection pipe as well. And what I want you to do in the next part of the tutorial is to actually draw this out, but I want you to provide different layers which represent different parts of this drawing. So for example, I'd like you to make up a layer called dashed or dash dot. Here again, dashed line, and make a layer for, say, granular subbase, because what you're going to do is you're going to create a polyline all the way around here to represent a boundary, and then you're going to hatch in between it. Okay, so just to give you an idea what we're talking about, if I was to take this particular feature here, which is the Marley geocellular feature, then you're going to have to work away by just taking some of this redundant geometry out and put in your own actual hatch. Okay. So try and take out what you've got there and try and put in the proper drafted version, is really what I'm saying. Okay, now you could use you could actually lock some of these and then be able to erase what you don't need. So if I now go into polyline and I go start point and take my ortho off there, then I can basically just draw a polyline around here. Now obviously that would be in a different layer, all the way back around, so that you're creating a proper closed loop. Okay, so there's your polyline, and then do your own hatch on that. Okay, so if you go up to the draw panel here, go into hatch, and then go down to where it says AR sand, which is here, then you can do your own hatch on that. Okay, so it's a proper drawing, right? Okay, so I want you to, then you can take out the boundary, of course, when you've done that, to leave you with something a little bit softer. But I want you to take this particular drawing and basically copy it, but make it into a proper drawing that's got proper text on it, because at the moment, these are just, these aren't proper these aren't proper text formatted features that you're looking at here. Okay, so I'm just going to stop the recording there, and that basically forms the basis of our tutorial.